Undersea cables are some of the means by which electricity and power, telephone calls and internet connections are transported throughout the world. With approximately 436 submarine cables operating worldwide, stretching over 700,000 miles undersea, cables make instant communications possible. Voice traffic that crosses international boundaries. Modern submarine cables also transport power from the land to offshore installations and platforms. With such importance, it is therefore necessary for repair and rehabilitation work to be done on these cables for optimum performance. In the deep sea, the ocean's inaccessibility largely safeguards cables. They need only to be covered with a thin polyethylene sheath. It's not that it's much more difficult to sever cables in the deep ocean. It's just that the primary forms of interference are less likely to happen. A skilled technician or jointer splices the glass fibers and uses powerful adhesives to attach the new section of cable to each cut end of the original cable, a process that can take up to 16 hours. The repaired cable is then lowered back to the seabed on ropes. Repair work is also required when these cables get accidentally damaged by shark bites, bottom trawling fishing boats, or the dropping of ship anchors, which sometimes cause damages. In such situations, the cable operator first needs to load which part of the cable lying on the seabed best cable ship with a team of underwater cable repair. Ford sails out to make the repairs. This team uses a special, the repair habitat, which serves as a platform for repair. Table section on the spot instead of lifting it onto a barge. When the bottom shell of the stainless steel chamber fits under the cable, while the upper shell clamps over it, there is then evacuated to dry the inside of the habitat, creating a vacuum for the cable. Air and humidity inside the habitat is monitored from electronic equipment on. The doors of the chamber are just big enough to allow the divers to put in their hands through its rubber padded gloves and repair the cables while looking in through its transparent roof. The chamber is already equipped with an underwater cable repair system and other necessary equipment required to complete the task successfully. Apart from the underwater chamber repair method, damaged subsea cables less than 6,500 feet below the water surface can be repaired by pulling the damaged section into a vessel and repairing them on the surface before resubmerging them. In this case, submersible robots are deployed with customized grapnels. They are able to pull the affected sections of the cable back to the ship or barge for easy repairs. However, when and cable has to be repaired, the cable is pulled out from the seabed onto the shore, then floated by means of plastic floats and a rope connected to a winch on the shore. After the necessary completed, a specialty designed diver-assisted water jet trencher buries the cable back into the sea at a depth of between 3 to 7 feet. The development of offshore wind farms has also necessitated the use of subsea cables to carry low-voltage control signals, data and communication signals, almost constantly be inspected for efficiency. One man-to-aerial vehicles launched from the decks of support vessels is to inspect the offshore wind farms for data collection. For some that doesn't understand how it works, many believe the global internet was made possible by satellites and simply isn't the case. The internet, believe it or not, is a physical network connected on land and under the ocean. A solution needed to be found how we could connect everyone across the globe after the invention of fiber optics. This technology soon. Fiber optic lines are run from town town and city to city on land. But when it comes to crossing the ocean, a special cable and ship was needed to pull it. Data is transferred on fiber optics or these strands of perfect glass with pulses of light when created. The bidirectional fibers are color-coded, with each color indicating a direction of data flow having a cable. Some specific engineering first. Public strands are the width. Human hair and are coated with gel to keep. In this first layer of protection in app, around the plastic tube are steel wires that add needed strength and protection. The next layer is made of copper, which not only adds additional strength but transfers power to repeaters. Repeaters are these canister-like devices that amplify the light every 50 miles or 80 kilometers. So the signal will make it to the other side of the ocean. The final layer, which insulates the entire package, this oceanic cable configuration. The cables placed near shallow areas close to shore or commercial fishing areas need more protection to additional layers of galvanized steel capped with nylon thread, and tar will be added for these areas. These cables are manufactured and spun in giant reels which go into pans in this large facility. See, they'll have around 100 pounds to finish the. When it's time to load the ship that will carry the cables out to sea, a series of conveyor belts called the cable highway pulls the cables into a large spool at the base of the ship's hull. An entire crew working 12-hour shifts for a month is what it'll take to get this ship ready to pull a new internet cable. The ship will make its way to its starting location. This is possible to the beach without becoming beached itself.